Yeah, very good morning to one and all. And today concept is about lexical analysis. Lexical analysis. And in this class, I'm going to deliver about the internal functionality of lexical analysis by showing the role of the structure of the role of lexical analyzer. By showing the structure of role of lexical analyzer. And before going to show the structure of role of lexical analyzer, see, listen some important points about the lexical analysis. Here, the process of compilation starts with first phase. That phase is nothing but an lexical analysis phase. We all know that. Why? Because we already learned in the concept like various phases of the compiler. And by learning that concept, what we understand is this lexical analysis is the first phase of the compiler. To do the process of compilation, this lexical analysis is acting as a first phase of the compilation. So the process of compilation starts with the first phase, that is called as an lexical analysis. And in this phase, the input is scanned completely in order to identify the tokens. By the definition of knowing what the lexical analyzer, we all know what the scan, what the performance of the scanner is. And what we're doing here, the input is scanned completely in order to identify the tokens. And the token structures can be recognized. Here, the token structures can be recognized with the help of some diagrams. These diagrams are popularly known as finite automata, finite state machine diagrams, transition diagrams. And to construct such finite automatas, what we are going to use is regular expressions. What it means is the specification that we are using here is in the form of an regular expression specification. The specification that here we are using in the form of an regular expression specifications. So the diagrams that we are using in construction of lexical analyzers are finite state machines or finite automatas. To construct such finite automatas, we are using regular expressions. To construct such finite automatas, we are using such regular expressions. So then these diagrams, whatever we constructed in the form of an finite state machines, that we are calling them as an transition diagrams or finite automata diagrams or finite state machines. And these diagrams can be translated into a program. These diagrams can be translated into a program for identifying the tokens. See here what the phase by phase levels that we are implementing here. First, by taking the input, scanning the input, then representing in the form of an finite state machines, and by using the regular expressions, and these machines are translated into a program for identifying the tokens. This is the process of performance of the lexical analyzer. Process of performance of the lexical analyzers. And here in this unit number 1, this is the second part that we are learning now, that is a lexical analysis. In this we will see that the role of lexical analyzer in compilation process, and also we are going to discuss I am going to discuss about the method of identifying the tokens from source program. And finally we are having one of the building tool in this concept that is in the lexical analysis, that is nothing but, and that tool is nothing but an lex tool. Here we're implementing that lex tool, and lex, which automates the construction of the lexical analyzer, This is the brief introduction about what the lexical analysis is. Now we are going in detail by learning the first concept in lexical analysis, that is role of lexical analyzer. See here, I shared the slide to you all. Once all of you see the slide, see this representation of the role of lexical analyzer. And now briefing out what the role of lexical analyzer is. As it is, we all know lexical analyzer is the first phase of the compiler. That is the first thing we have to write when describing about the role of lexical analyzer. Lexical analyzer is the first phase of the compiler. And what the second thing that we are performing here is the lexical analyzer reads the input source program from left to right, one character at a time. Make a note of this. Reading the input program not at a time. At a time, the whole program is not going to be scanned. How the process is to be done while scanning. Reads the input source program. Reading the input source program from left to right. Scanning the input from left to right. Starting from left and ending to right. From left to right, one character, reading and one character, and identifying or recognizing the token for that character, and go for the next. Go for the next character. And after recognizing the token of that next character, and go for the next. That is the process of scanning. At a time, the whole program is not going to be scanned here. How the process of scanning is going to be done? Reading an input program from left to right, one character at a time, and it generates the sequence of tokens. And generates the sequence of tokens. And here, each token is an single, each token is an single logical cohesive unit. That means those tokens can be called as an identifiers, or they can also be called as an keywords, or they can also be called as an operators, or they can also be called as an punctuation marks, and so on and so on. We are having different of tokens, but while coming to depends on the program, we are choosing what type of a token we are recognizing, that what type of a token that we are giving the name of that particular character. And then the parser to determine up to this the lexical analyzer phase is completed. Up to this the lexical analyzer phase is completed. What the steps that I explained now? First, reading the input source, that is reading the source program from left to right, and taking one character at a time and generate the sequence of tokens, and each token is a single logical cohesive unit, and that can be called as, and such as those logical cohesive units are nothing but an identifiers or keywords or operators and punctuation marks, and so on. And this is the performance that we are performing. This is the task that the lexical analyzer is going to be performed. And then what the next step is, the parser to determine the syntax of the source program can use these tokens. See here in the structure we're having the two phases, phase 1 and phase 2. Phase 1 is an lexical analyzer phase and phase 2 is an parser phase. Yet the both phases are connected to an symbol table. And see, initially we are taking an source program, and after we are taking an source program, and after taking the source program, this source is given to the lexical analyzer. The source is given to the lexical analyzer, and taking the source and scanning the input program from left to right, reading an input character by character, and generating a token, generating a sequence of tokens from the input program, and that each character is converted into a token. That token is sent to the parser. That token is sent to the parser, and this parser will ask the lexical analyzer to get for the next token. Ask the lexical analyzer to get for the next token. For example, in the last class, we see the example with an position is equal to initial plus rate into 60. That is the translation statement that we implemented by using the phases of compilers. See, position is equal to initial plus rate into 60. That is the source program here. Taking an example of the translation statement, that is the source program here. Now the position, reading, scanning the input from left to right. Left to right means here the left character, from by starting from the left, what the first character I need to read? Position. And reading and position and scanning that position, by scanning that position from left to right onwards, and individual character, reading the input statement, input translation statement by character, not the whole statement at a time, not scanning the whole statement at a time. Now I am recognizing what type of an identifier, what type of an token it is, by taking an character position, and I naming it as an identifier token. So now I am sending that identifier to the parser, and this parser ask for the next token, and again I am reading an is equal to, where is equal to is an assignment operator. There is no change in the operators while converting from characters to tokens. So is equal to is same as an is equal to, that is an assignment operator. Now that reading the assignment operator is equal to, and I am recognizing that the token name of that is equal to assignment is an assignment, and now I am sending that assignment operator to the parser, and this parser asks for the next token. Like that, the role of parser is going to be executed. The role of parser is going to be, that means the role of lexical analyzer is going to be executed, and giving the demand for the tokens from the parser, sending the tokens to the parser, and the performance is done by the lexical analyzer. The task is done by the lexical analyzer. Then the parser to determine the syntax by using these tokens. What the next step of the parser is, by using this, it determines the syntax tree. It determines the syntax of the source program you that can be used by the use these tokens. By using these tokens, by implementing the parser phase, then finally the output of the parser is an syntax tree. The parser produces an abstract syntax tree, that is an hierarchical structure, that we can also be called call as an parse tree. But here our concept is about role of an lexical analyzer, so we need to learn about an lexical analyzer. We need to learn about an lexical analyzer, where knowing about how the internal functionality of the lexical analyzer is going to be done by seeing this structure. And as the lexical analyzer scans, as the lexical, here this is the role of analyzer in the process of compilation. The structure is a role of analyzer in the process of compilation. I think up to now you all understand how the role of lexical analyzer is going to be executed, and what the internal functionality of the lexical analyzer is. And then as the lexical analyzer scans the input program to recognize the tokens. For what it is doing the scanning means, only the main task for performing the scanner is to recognize the tokens for the input string, for the input program. Recognition of the tokens, recognizing the tokens from the input source code. That is the main task of the lexical analyzer. How it is going to be recognized is just by scanning the source program from left to right and reading character by character and naming the character into an token. That means converting the character into an token. That is the major task that the lexical analyzer is going to be performed. And apart from token identification, identification, this lexical analyzer also performs some functions. Make a note of all those functions what I'm going to explain now. The lexical analyzer also performs the following functions. What the functions of the lexical analyzers are? The first function is produces the stream of tokens. Produces the stream of tokens. That is the first function of the lexical analyzer. And this is the most important function, the second one. It eliminates blanks and comments. We're having blank spaces, white spaces, and comments like that. And by using this lexical analyzer eliminates the blank and comments. Blank spaces and comments are all are eliminated by the lexical analyzers. And what the next function of this lexical analyzer is, it generates an symbol table. It generates an symbol table. And see here in the structure, we are having a representation with a symbol table, and that the symbol table is connected to the both lexical analyzer and the parser. It generating a symbol table which stores the information about identifiers, constants, and encountered, whatever the thing that we done, those are all to be encountered in the input. Those are all to be encountered in the input. So it generates the symbol table which stores the information about the tokens. Stores the information about the tokens. And what the next function of the lexical analyzer is, keeping track of line numbers. Keeping track of line numbers. Line numbers. And the next feature, the next function of this lexical analyzer is error count encountered while generating the tokens. And always the lexical analyzer reports the errors which are to be encountered while generating the tokens. And Here we're having another subphase, that is an error handler. This error handler always handle the error there itself in each and every phase. At the place of each and every phase, there itself we are encountering those errors and we are rectifying those and we are modifying the code. So it reports the error encountered while generating the tokens. And finally, how we're describing this lexical analyzer means, lexical analyzers works in two phases. The first phase, in the first phase, it performs the scanner. It performs the scan. And in the second phase, it does lexical analysis. Means it generates the series of tokens. Again, I'm repeating what the functions that I explained now about the lexical analysis. The first one is an produces the stream of tokens. Make a note of all these functions. Produces this stream of tokens. And the second one is an eliminate blank and comments. Eliminate blank spaces and comments. Eliminate blank spaces and comments. And the next one is an generates the symbol table which stores the information about the tokens. Generates the symbol table which stores the information about the tokens. And this is the task that is performed by the lexical analyzer. This is the task that is performed by the lexical analyzer. And the next one is an keeping track of the line numbers. Keeping track of the line numbers. And the next one is an reports the errors encountered while generating the tokens. Reports the errors encountered while generating the tokens. And these are the 5 functions that I explained now. These are the 5 most functions after performing the lexical analysis. After performing the task of the lexical analysis, we can define these 5 functions, most important 5 functions of the lexical analyzers. Finally, how we are going to describe this lexical analyzer means describing in 2 phases. One, the first phase, it scans the input program, and in the second phase, it does the lexical analysis. That means it generates the series of tokens. That is the task, that is the role of the lexical analyzer that is going to be performed here. The role of the lexical analyzer that is going to be performed. I think you all understand the role of an lexical analyzer by briefing out the structure and by explaining about the functions of the lexical analyzer and in how many phases that the tokens are going to be generated in the lexical analyzer, how the lexical analyzer is subcharacterized into 2 phases. The lexical analyzer is subcharacterized into 2 phases. One for scanning and another for performing or doing the lexical analysis. That means generating the tokens. Where the first, while writing the answer for the role of the lexical analyzer, the first thing that what we have to write is the lexical analyzer is the first phase of the compiler. The lexical analyzer is the first phase of the compiler. And what the next thing is, what the main task that the lexical analyzer is going to be performed. That means the role of the lexical analyzer is reading the input characters and produces an output as a sequence of tokens. Means that the parser uses for syntax analysis. Whatever the output that we are going to generate at the part of lexical analysis is acting as an input to an parser. Means these tokens are useful for generating the tree structure by implementing the parser. So up to this concept, we need to concentrate mainly on the lexical analyzer and the symbol table. And here we need not to worry about what the parser and what the internal functionality of the parser is. Just why the representation consisting of this parser means, and after generating the stream of tokens, these tokens are going to the parser phase. These tokens are taken by the parser. So that's why the representation consisting of an parser. But we're not explaining anything about the parser here. We're only concentrating mainly on the role of the lexical analyzer, not about the parser. Just we're saying that here, after generating, from where the output we are sending. And the sequence of tokens, generating the sequence of tokens, and these tokens are taking as an input for the parsers. These tokens are acting as an input for the parsers. That means always the parser demands for the tokens from the lexical analyzer, and the lexical analyzer generates this stream of tokens and send to the parser. By using these stream of tokens, the parser is going to generate an abstract syntax tree. And this is nothing but the description of role of lexical analyzer. The description of role of lexical analyzer. I think you clearly understand about this. And now, what the issues in the lexical analysis is. Here we are having some of the issues here. There are several reasons for separating the analysis phase of the compiling into lexical analysis and parser. See how many parts, the parts of compilers are two parts. Parts of compilers are two parts. One is an analysis part and another one is an synthesis part. This concept that we already learned in the last classes. Again, I am recalling that. Two parts of compilers. One is an analysis and the another one is a synthesis. Again, this analysis part is characterized into three sub parts. What are those? Lexical analysis, syntax analysis, and semantic analysis. See, that's what here we're having a statement for that. There are several reasons for separating the analysis phase of compiling into lexical analysis and parsers. What are those reasons? Here the mainly we're having three most important reasons for separating the analysis phase of compilers into lexical and parser. One is to simple to design, and another one is an efficiency, most important point term, and the next one is an portability. Next one is an portability. Simple to design and improve the efficiency, and it should be an portable. Compiler should be an portable. And these are the three most reasons for separating the analysis into these two phases. These two phases in the sense lexical analysis and the parsing. And here we are using some specialized tools for designing the lexical analyzer. That means to help automate the construction of lexical analyzer, here we are using a specialized tool. That tool is nothing but a Lex tool, Lex tool. In the last class, I explained about the compiler construction tools. There we are having one of the tool that is a scanner generator. And here we are implementing that scanner generator. We are implementing the scanner generator in lexical analyzer. And the tool that we use it for implementing the lexical analyzer is Lex, Lex. That is a specialized tool. That is a specialized tool. It is having another name, that building tool of an compiler. It is one of the building tool of an compiler. By using that tool, it helps to automate the construction of the lexical analyzer and the parser when they are separated. When they get separated, both the lexical analyzer and parsers, when they get separated, and these tools are helpful for implementing. These tools are helpful for implementing and also to help the automate the construction of the lexical analyzer. These are the important reasons, that most important reasons for separating out the analysis into lexical and parser. One is simple to design, another one is efficiency, improving the efficiency of the compilation code, and next one is an compiler portability. And these are the issues in an lexical analysis. And next one, most important thing, by using the another subphase, that is an error handler. How the error handler phase is going to be implemented, how the task that is going to be performed, what type of a task that the error handler is going to be performed. And in the name itself, I already explained the error handler, handling of the errors, where it is going to be handled after compiling or after performing the overall implementation of all the phases, or at the phase by phase level, and handling the errors at phase by phase level, level, and rectifying those, detecting those errors and rectifying those, and making some modifications, and again recompilation, doing the recompilation by using the incremental compilers, and finally generating an output. In the form of, it may be an lexical analyzer generating an tokens, it may be an syntax analyzer generating an syntax tree, it may be an semantic, giving the meaning, determines the meaning of the syntax tree, the abstract syntax tree, or it may be an intermediate code generator, and by representing in the form of an 3 address code. If we get any errors, they're handling those errors in the templates and rectifying those and making them, so making some modifications and finally generating the output in the form of an intermediate code representation. And same for the code optimization. Again, there also, after rectifying any errors, the output in the form of an intermediate code representation. And finally, the last phase of the compiler, that is a generator, code generator, and the absolute target code. We need to generate an absolute target code. If any, by converting into a machine level language, if we get any errors, like an machine taking of the registers, or storing in some registers, or placing the memory locations of those, or using some data types, or using some arithmetic logic units. In all these cases, we can, if we get any errors, in all these cases, we can rectify those, and finally we can generate the absolute code. That's it. That's about the error handler. And now, what type of an lexical errors that we can get? See the slide, all of you. See the slide, all of you, once. Lexical errors, lexical phase errors. And these type of errors can be detected during lexical analysis phase. Typically, lexical phase errors. Typically, we are calling them as an lexical phase errors. For example, where we will get some errors like spelling errors, hence get incorrect tokens. For example, I scan the character like in position. When I am converting it into a token, in the place of an identifier, if I use any token like a keyword or any punctuation, there it is a mismatch. There will get a mismatch to recognition of the token. Why? Means the character can be converted into an token in the form of identifier. Isn't it? But not in the form of an punctuation mark. So if the code consisting of like that means the conversion, if we converted in the form of mismatch, by giving the mismatch identifiers, by giving the mismatch tokens, then there we can identify an error like incorrect tokens. That means spelling errors. And exceeding the length of identifiers or numeric constants, and these are all inbuilt lexical phase errors that we can easily understand while converting from characters to tokens. Appearance of illegal characters. This is also can be an error. Length of the identifiers or numeric constants, and exceeding of all these, or spelling errors or incorrect tokens, mismatch errors. Mismatch in the sense, if the token, the identifier of the token is one, but we are matching with the another type, then we get an mismatch token. So these are all considering as an errors, lexical errors. So we can easily identify these errors, and we can easily detect those and rectify those, and finally we can make our code error free. And these are all nothing but an lexical errors. See here in the slide, there are some points. We can, by implementing the lexical level itself, we can rectify some, we can find out some errors, and we can rectify those errors. Because why? Because lexical analyzer has very localized view of a source program, and some other phrases can also handle some panic mode errors like an error recovery. And these are some of the errors that we can identify by implementing the lexical analyzer. Normally, due to type mistakes, the wrong spellings may appear in the program. This causes an lexical error. That means typing mistakes, the wrong spellings may appear. Those can be called as an lexical errors. right? And with this, you all understand about what type of a lexical errors that we can handle while implementing the lexical analyzer, and these are the issues in lexical analyzer, and this is the role of the lexical analyzer. And in this class, what I explained you all is about the giving the description about what the lexical analysis is. That means giving an introduction about what the lexical analysis is, and then explaining about what role of lexical analyzer with a neat structure, and also explaining about what the functions of the lexical analyzer is after performing the role, what type of functions is having for the lexical analyzer, functions for lexical analyzer, and then the issues in the lexical analysis, and finally the last concept for today's session, that is on lexical errors. I think you all are clear about these three concepts about the role of lexical analyzer and what type of an issues that we're getting when we're implementing a lexical analysis phase, and finally what type of an errors that we can encounter while implementing a lexical analysis phase. Always the output that we're generating from each and every phase should be an error-free output. These are the today's concepts that I deliver to you all. And for tomorrow concept, I'm explaining about what the token is, what the pattern is, what the lexeme is. By briefing out with an examples, I'll clearly explain what the token, what the pattern, and what the lexeme is. And then going in detail about input buffering. This is another concept, that is an input buffering concept. Learning in detail about input buffering, how to store the buffer, store the input in an buffer, how many ways that we're going to store the input in the buffer, and all this we are learning in the next classes. And tomorrow session is about the tokens, patterns, and lexemes, and the concept of input buffering. Tokens, patterns, and lexemes with an example, and the next concept is about an input buffering.